On this episode of Global Topic, I'll have a conversation with Matt Valentine, Strategic Account Manager with Chlor-Rid. Matt and I will have a conversation on the topic of soluble salts and coating performance. Welcome to Global Topic, the go-to series for the global corrosion and protective coatings industries, exclusively here on YouTube. In this series, you'll find technical content, information, and the latest industry news and events. And now for our interview. Hey, Matt, welcome to Global Topic.
Hey, Jim. Nice to be here. I appreciate you allowing me to come on and talk about salts.
Hey, if you could do a favor for the viewers of the episode, if you could cover your professional background, and also if you could talk about Chlor-Rid and give a background on Chlor-Rid.
Sure, no problem. My background is for the past 30 plus years has been industrial coatings, and I've been in the coatings market in various aspects, residential, commercial, industrial. Spent a lot of time in industrial. I'm a NACE certified level 3 coatings inspector. And I've been with Borchers now a little over a year, almost a year and a half now. And, you know, Chlor-Rid was developed back in the early 90s, been around for quite a while, well established in the marketplace. In the early 2018, the company out of Cleveland, Westlake, by the name of Borchers, purchased Chlor-Rid. And since that time, up until February of this year, 2020, we were acquired by the Milliken Company based out of Spartanburg, South Carolina. So that's kind of the history of where we are today. So, you know, we've been around quite a while, and we keep introducing new products. And of course, we have our existing test kits and our original liquid products as well.
So, Matt, let me ask you this. You know, what does soluble salts mean? And what falls under the term of soluble salts?
So the actual definition, according to SSPC, their definition of soluble salts is an ionic chemical compound that dissolves in water to form a solution of positive and negative ions. So, you know, soluble salts are both visible and non-visible. So you see white salts on a vehicle that you could easily wash off with, a garden hose typically. And what we were concerned about are the non-visible contaminants and the non-visible salts, which the most corrosive salts that we deal with are the chlorides, sulfates, and nitrates. So you have the loose ones, as I've mentioned. Again, those come off very easily. The ones that are non-visible, they typically are electrochemically bonded salts. They bond themselves to the metal substrate, such as steel and zinc coatings. So most salts come from, de-icing liquids, marine bodies, chemical processes, typically fossil fuels. You'll find sulfates in those. And those are just a few sources that we deal with. So they definitely create a huge problem when you are coating a substrate. And typically, if you're not testing for salts, you risk the possibility of coating over the salt ions that are attached to the substrate, which creates a premature coating failure. And that's typically because what happens is most coatings that are applied or in any aspect of the industry are permeable to some degree, some more so than others. So when you get into the salt ion being underneath of the coating, and you have moisture that actually passes through the coating system, it reacts with the salt ion and creates a corrosion cell. I think everybody's had to deal with the salt shaker in a highly humid area where they always have to put rice in it to keep it from clumping up. Salt will attract moisture and absorb it into the salt So that's why when you have the salt ion underneath of the coating system and then the moisture passes through the coating, that creates the corrosion cell. And our goal is to eliminate the salt ion completely. So when that moisture actually passes through the coating, there's nothing there to react with it. So you don't have that problem.
Matt, that was very interesting, your description related to corrosion. So let me ask you this, how can residual soluble salts create corrosion issues that impact an installed coating system? How would they manifest? What would they look like with a coating system?
So what happens is the salt ion is attached to the steel substrate. So when you coat over that salt ion, you have moisture that will pass through a coating. So all coatings are permeable, and they all have varying rates of permeation. So, some take longer than others. But what happens is that moisture will pass through the coating, and it will react with the salt ion itself. And that's what creates the corrosion cell. So, it's not like water actually, you're seeing droplets of water passing through. It is, the moisture vapor in the air that will actually permeate that coating. And it will create a corrosion cell. And what happens, it looks like, starts out like a pinhole, and then it'll start undercoating and corroding up underneath the coating system. And eventually the coating system will fail.
So once testing has been done related to soluble salts, and it's been determined that the steel substrate will need additional cleaning for the soluble salts, what can be done with process and product solutions to clean?
Well, first of all, the testing is critical. There's varying ways of testing. There's the Bresel test out there, which is a conductivity test. And then the other tests out there are our test kits, which are ion specific. So you want to know what salt you're dealing with and how much you're dealing with. So our test will give you an actual reading of parts per million. A conductivity test, it will tell you it's conductive, but that doesn't necessarily mean you're dealing with corrosive soluble salts. You could have metals, other soluble product that will be conductive, but yet they're not corrosive. So what happens there is if you come out with a conductive positive test, you're doing all of this, removal of processes that add to the job costs. And a lot of times, you can have false positives, and you're adding all of that extra cost to the project that you really don't need to. So that's the most critical part is actually the testing process. So, once you get through and determine that you do have salts on the substrate, we have a product that's called Chlor-Rid, of course. It is a slightly acidic product. And we feel that being slightly acidic, if you go into a shop that processes steel and cleans steel, they always use typically an acid bath to clean the steel. Unfortunately, we can't do that in the field because of EPA environmental issues. So with our product being slightly acidic, it is biodegradable, so you don't have to worry about that product going anywhere, going into the water supply or the ground or whatever. So we have all of those tests that approve that product. So what happens is you've determined you have salts. So what you do then is you come with a 1% solution. You can go as high as 2%. We've had some customers even go higher than that. You mix it with a pressure washer, 2,500 to 3,500 PSI, and you pressure wash the entire surface to remove the salts. Now, one of the challenges there is that you're dealing with a lot of salt, so you have to retest afterwards. And that product being slightly acidic will always have a tendency or always will flash rust the substrate. So you'll need to, once you've retested and determined that the salts are gone, you'll sweep blast the steel and then coat your substrate. A lot of times we have customers that, they may not be able to get back on it quick enough. So what they'll do is they'll come back through, they'll sweep blast or vapor blast with our product called Hold Blast. And it's it's an alkaline-based product, so what it does, it'll passivate the steel for up to 72 hours. So it allows them to get back onto the steel or leave it overnight without having any rusting issues.
Very interesting. So, you've gone through and you've cleaned, can the presence of soluble salts ever be completely removed? Is there any data that shows, by just reducing levels, it's okay for most coating systems to perform well?
Definitely. According to a JPCL article that was published in 2001, I believe, Howard Mitchke, who worked for Shell Global Systems at the time, conducted an extensive study on the impact of salts on coating performance. And he determined that just 1 ppm of salt on the substrate has the potential to reduce the coating life of the system 50%. We had some pictures. I don't know if you've got them there. You can put them up. It's the chloride limited impact. We actually did testing in our own lab. So we took an actual coating lining system. We sprayed them on 4 coupons. We had 2 of them at 10 parts per million of chlorides. And then we had our control. We boiled it in DI water for 24 hours in 6-hour increments. And then we did our adhesion pools. And the dollies for the 10 ppms, the adhesion ratings on the one panel was 719. The other panel was 648 psi. That was what it took to get bare substrate failure. Then our control, we did the same testing on that. And we had psi ratings on the one coupon at 1,029 and the other one at 1,034. And we had, it was just the coating system still adhered to the steel.
So, what recommendations do you have for asset or facility owners, when it comes to addressing soluble salt testing within their specifications and their coating project documentation?
Yeah, this is a real issue that we've been working hard on is getting the owners to recognize, first of all, that soluble salts will inhibit the life of the coating system. So we always put into the specification requiring ion specific testing. So we always reference the ISO standard 8509-5. Which details out how to do the testing specifically for ion testing. And then we also include 2 other documents. One of them is an SSPC Technology Guide 15, and that is actually a descriptive method on how to extract and analyze soluble salts on steel and other non-porous substrates. Then the other document that we also include is the SSPC Technology Guide 24, which is a soluble salt testing frequency. And what that describes is, it's like PA2 when you're doing DFT ratings. This gives you a guide on how many tests per square feet you should be doing on a specific substrate. So, those 3 items right there are pretty critical into a specification. And then, of course, we always recommend, writing our product in specifically for the removal of salts. So those are the 4 big issues that we always include in a specification.
Perfect.
Now, keep in mind, though, that there are many committees still working on other standards that will eventually come out in the near future as well. So that we'll incorporate any future documents as well.
Excellent. Matt, this has been a great conversation. Is there anything that we didn't cover that you'd want to leave with the viewers of this episode?
Well, one of the issues that we're getting back from coating manufacturers, they're always concerned about something being left on the surface. So that's a big issue with customers. So we developed a product called Hold Blast Vision. And what that is it does take off salts, but it doesn't take them down to the non-detectable. It'll take them down to low levels. So what that product will do for you is it actually has a visual inspection. You can actually take a black light and run it over the surface, and you can tell right away whether it still has residue on there or not. And the nice thing is, if you detect it, all you need to do is rinse it back off again. We have we have on our website is a video of that, and it shows a real life at a salt plant in Cleveland, that real life on what it can do.
Very good. And for the viewers, I will have links to that video. It's a YouTube video. I highly encourage everyone to watch it. It's very informative, provides a lot of good information. Additionally, Matt had mentioned several standards and guide documents that I'll also have links to related to those particular documents to take a look at, and a link to the Chlor-Rid website as well. Matt, thank you so much for this opportunity to have a conversation with you today.
I appreciate the time. Thank you, Jim.
Hey, have a great day.
You too.